The activity recorded in June 2026 marks a specific shift in how global institutions are anchoring AI into their permanent infrastructure. JP Morgan Chase has moved AI out of the experimental budget entirely. Their 2026 technology spend includes $19.8 billion and 2,000 staff focused solely on AI development. Meta is currently executing a restructure that cuts 8,000 jobs while repositioning 7,000 other employees into its applied AI engineering and agent transformation units. Apple's WWDC keynote confirmed this trajectory, with iOS 27 integrating Gemini and Claude as first-class options within the system's core AI architecture. This chart shows the financial result. OpenAI and Anthropic are now pulling in a combined $40 billion in annualized revenue, a market that barely existed 3 years ago. For enterprise leaders, deploying these systems has become the absolute baseline requirement to operate. However, that adoption curve is now intersected by a spike in friction, as hardware limits and new compliance laws begin to dictate the pace of deployment. The ecosystem has split into two distinct tiers: massive frontier models for deep reasoning and hyper-efficient production models for high-speed tasks. Selecting the wrong tier for a high-volume workload leads to cash hemorrhaging through unnecessary compute costs. There is also the operational risk of facing legal liabilities or being out-innovated by competitors using more specialized, faster tools. Managing these risks requires moving away from a single model approach toward a heterogeneous tech stack. To survive this shift, organizations must rigorously map specific models to their exact business workloads. This mapping starts with the most demanding workflows: back-end agentic coding and autonomous security protocols. In our comparison table, Claude Opus 4.8 represents the premium input tier, with fast mode pricing at $10 per million input tokens. That investment produces a 69.2% score on SWE Bench Pro and fueled Project Glasswing's discovery of over 10,000 high-severity zero-day vulnerabilities. Critically, Opus 4.8 is 4 times less likely than its predecessor to silently ship buggy code, a vital metric for production-grade agents. For these tasks, developers are trading higher per-task inference costs for the reliability of code that actually works in production. In mission-critical environments, the cost of premium inference is significantly lower than the cost of engineering hours spent fixing AI-generated hallucinations. When the enterprise workload shifts toward massive, unstructured data ingestion, the total size of the context window becomes the primary requirement for success. Gemini 3.1 Ultra processes 2 million tokens of native video, audio, and text in a single prompt without using transcription middleware. Adding this to our table, the outcome is the removal of traditional RAG pipelines, simplifying the software architecture for massive internal datasets. The trade-off is that Ultra shifts the complexity of the task directly onto your hardware and memory requirements. To manage those compute costs, efficiency-focused tools like Gemini Flash-Lite and the TurboQuant algorithm provide a secondary path. TurboQuant reduces the memory overhead for long context windows, allowing 2 million token models to run without data center scale RAM. As the third row shows, Flash-Lite drops input costs to 25 cents per million tokens, while increasing response speeds by 2.5 times. The strategy here is to restrict Ultra to high-value analytics, while routing high-volume routine tasks to Flash-Lite. Technical performance is only half of the equation. Legal compliance now dictates the actual deployment timeline. The Colorado AI Act, taking effect at the end of June 2026, establishes the first comprehensive liability framework in the U.S. It targets any high-risk AI system used in employment and healthcare, housing, or financial services. The final row of our matrix shows the requirements: formal risk management programs and annual algorithmic impact assessments. This legal layer significantly extends the time to market for any new enterprise AI feature. Regulatory compliance functions as a mandatory operational cost, determining where and how these systems can be launched. These software and legal strategies are ultimately bounded by the physical infrastructure available to run them. NVIDIA's Vera Rubin supercomputer platform entered full production. To solve the memory bandwidth bottleneck, NVIDIA certified HBM4 memory suppliers like SK. This includes a co-development pact with SK Hynix to build full-stack AI factory clouds and digital twins for chip manufacturing. Memory bandwidth has become the physical constraint that determines which platforms can actually support frontier-scale training at a manageable cost. This decision framework routes your workflows based on your primary organizational goals. Developers should lean on Gemini Flash-Lite for consumer chat, but reserve Claude Opus 4.8 for the coding agents that manage your internal codebase. IT leaders can utilize Gemini Ultra's context window to replace complex RAG pipelines for deep internal data analysis. However, all enterprise deployments must be gated by a formal Colorado AI Act compliance framework. For strategists, the true leading indicators of scaling capability are now found in memory innovations like HBM4 and TurboQuant. Success in this landscape requires architecting a stack that balances high-end reasoning with the realities of hardware limits and legal requirements.